titled Complex Numbers Of course, the first few problems I have already discussed with you. If I said mod z minus z1 plus mod z minus z2 is mod of z1 minus z2, then where z1 and z2 are points A and B, fixed points A and B, then this statement is like, if there is a point P which is z, then this statement is like PA plus PB equal to AB. P can be anywhere on the line joining A and B. I also told you that if this is this minus this, then this is like PA minus PB equal to AB. That means P can be anywhere to the right of B. Right? I've also told you that if this plus this is a constant C bigger than AB, then the locus of Z would be an ellipse whose foci are A and B. If this is C which is less than AB, a constant C less than AB, and this is a minus sign here, PA minus PB, then the locus of P is going to be a hyperbola with foci A and B, right? Then if this is Z1 and this is Z2, and P is a point such that mod Z minus Z1 is mod Z minus Z2, which is the next problem. Mod Z minus Z1 equals mod Z minus Z2. That means P moves in a manner that its distance from Z1 is the same as its distance from Z2. Then the locus of P must be the perpendicular bisector of the line joining Z1 and Z2. P can lie anywhere on the perpendicular bisector. In fact, it's a special case of the earlier one where K is 1, which is a circle, which is a straight line, which is actually a special case of a circle with infinite radius. Yes or no? Right? With infinite radius. So, I just now discussed with you problem part 6 also. Mod Z minus Z1 is K times mod Z minus Z2 is going to be a circle whose inverse points are Z1 and Z2. Right? Okay. So we've taken care of different parts of one already at various times. Right? Let me look at B. There is a quadrilateral with vertices ZA, ZB, ZC and ZD, such that ZA plus ZC is ZB plus ZD. We want to check on the nature of this quadrilateral. Now, what this means is ZA minus ZB is ZD minus ZC. ZA minus ZB is this vector, right? It's the same as ZD minus ZC, which is this vector. If these two vectors are equal, then these two vectors are equal means they are not only parallel, they are equal in magnitude. That means opposite sides are equal in magnitude and also parallel. Then this must be a parallelogram. This must be a parallelogram. ABCD must be a parallelogram. A rectangle is only a special case of a parallelogram, isn't it? A rectangle is only a special case of a parallelogram. Also, do you see that ZA plus ZC by 2, ZA plus ZC by 2 is the midpoint of AC, and ZB plus ZD by 2 is the midpoint of BD. Diagonals of a parallelogram bisect each other, isn't it? ZA plus ZC by 2 is midpoint of AC, and ZB plus ZD by 2 is the midpoint of BD. And AC and BD have the same midpoint, means they bisect each other. Diagonals of a parallelogram bisect each other. So we've all learned ZZ bar plus A bar Z plus AZ bar plus B represents a circle. Did I teach this to you in the past? Where A is a complex constant, B is a real constant. Yes or no? The center of the circle is given by minus A. Yes or no? Did I tell you this in the past? The center of the circle will be given by minus A. The radius of the circle would be given by mod A whole squared minus B. That's the radius of the circle. Have I told you this? Right? Now we have a circle which is like ZZ bar plus minus 6 plus 8I Z bar plus minus 6 minus 8I Z plus K equal to 0. In this case, this must be A and this must be A bar. A Z bar. So the complex constant A of the circle is minus 6 plus 8I. Yes or no? That's so the center of the circle is going to be minus A, which is 6 minus 8I must be the center of the circle. Right? The radius of the circle is going to be root mod A squared. Mod A squared is 100 minus B. B is K in this case. For this to be a circle, K must be less than or equal to 100. For this to be a circle, K must be less than or equal to 100. K equal to 100 will represent a point circle. Circle with 0 radius. So for this to represent a circle, K cannot exceed 100. All's good? Shall we proceed? We want to find the value of A. Clear? Hey, look at this. Look at this. One way to look at it is geometrically, right? Suppose this is a vector Z1, right? This a vector Z2. Then from parallelogram law of vectors will apply to this. This vector must be Z1 plus Z2. Yes or no? Now if this is Z2, then this vector will also be Z2. Yes or no? And what's given is this length is mod Z1 plus Z2. This length is mod Z1. This length is mod Z2. Yes or no? Do you realize what I'm saying? And from Pythagoras theorem, if this square is this square plus this square, then this must be 90 degrees. Yes or no? Right? If this be the condition, it must constitute a right angle triangle, and therefore this is 90 degrees. And if this is 90 degrees, can I say argument of Z1 by Z2, the amount by which you must rotate the denominator vector so that it coincides with the numerator vector, could be plus or minus pi by 2, depending on their relative orientations. Yes or no? And if the argument of a complex number is plus minus pi by 2, it must be purely imaginary. That means Z1 by Z2 must be purely imaginary. And therefore, A must be 0. A must be 0. Yes or no? Now, also there is another way of looking at things, algebraic way. So this was a geometric way of looking at things here. Let me look at it purely algebraically as well. Okay, can I wipe this off? See, a result, I'm not sure if I have communicated that result, but in case I haven't, take cognizance of it now. See, mod of Z1 plus Z2 whole squared, I claim is mod Z1 squared plus mod Z2 squared plus twice real part of Z1 Z2 bar. I have not told you this result, right? No? It looks Greek. Nevertheless, let's make it Latin. Okay? See, mod of z squared is zz bar, right? Mod of z squared is zz bar. Which means mod of z1 plus z2 whole squared is going to be z1 plus z2 into z1 bar plus z2 bar. Yes or no? Can I do this? Z into z bar. Bar of this would be sum of the bars. Yes or no? Diptesh. Which is like z1 bar, which is mod z1 squared, z2 bar, which is going to be mod z2 squared, z2 z1 bar plus z1 z2 bar. Yes or no? Hey, if I take the bar of z1 z2 bar, what will I get if I took the bar of this? z1 bar, z2 bar, which is z2, right? Which is this number. So if this is z, then this is going to be z bar, right? This is going to be z bar. Z plus z bar will be twice real z. Z plus z bar will be twice real z. Yes or no? Right now? So I could have said then, this is mod z1 squared plus mod z2 squared plus twice real z, because if this is z bar, twice real z, which is z1 z2 bar. Yes or no? Similarly, we could have established mod of z1 minus z2 whole squared. Same way you can show is equal to mod z1 squared plus mod z2 squared minus twice real z1 z2 bar. Right? These two are useful algebraic results. Let me add them. We end up getting mod of z1 plus z2 whole squared plus mod of z1 minus z2 whole squared is twice mod z1 squared plus mod z2 squared. This is what you get. Let me look at the geometry of this final result. Right? Both these results as well as this culmination result, they are useful. Now let me look at the geometry of this result. Okay. Say this was a vector z1, all right, and say this was a vector z2. Now if I complete this parallelogram, then this would be z1 plus z2. this vector would be z1 plus z2 vectorially, right? This vector would be from triangle law vector z1 minus z2. This vector is going to be z1 minus z2. Say this parallelogram was ABCD. This is the square of one diagonal, this is the square of the other diagonal. Mod z1 plus z2 is AC, mod of z1 minus z2 is BD. So this result is like AC squared plus BD squared, sum of the diagonals of a parallelogram, equals mod z1 squared plus mod z1 squared, mod z2 squared plus mod z2 squared. That means mod z2 squared plus mod z2 squared is like AB squared plus CD squared. Mod z1 squared plus mod z1 squared, if this is z1, this will also be z1, which would be like AD squared plus BC squared. Yes or no? Which means the sum of the squares of a diagonals of a parallelogram would be sum of the squares of its sides, which is a regulation result in geometry. Sum of the diagonals of a parallelogram would be sum of the squares of its sides. Clear? Now, I have told you this result. Now the original problem that we were supposed to handle using this result, right? Can I wipe those off? See, what was given was mod of z1 plus z2 whole square is mod z1 squared plus mod z2 squared. So this I could, left hand side from the result that we just derived, could be written as mod z1 squared plus mod z2 squared plus twice real part of z1 z2 bar yes or no? Right? Which means this must be 0. This part must be 0, right? That means real part of z1 z2 bar must be 0. Right? Now z1 z2 bar can be looked upon as z1 by z2 into z2 into z2 bar, which is like z1 by z2 into mod z2 squared. The real part of this must be 0, but z1 by z2 is taken as a plus ib, right? So a plus ib, z1 by z2 we took as a plus ib into mod z2 squared, that must be 0. Real part of this must be 0. What's the real part of this? A into mod z2 squared. Mod z2 is a real number, right? So a into mod z2 squared, that's the real part of this, that must be 0, which will give us a equal to 0, given that mod z2 is not 0. Right? The roots of this equation, quadratic, z1 z2 and the origin z3 equal to 0. The roots of this equation z1 z2 and the origin, which is z3 equal to 0, constitute an equilateral triangle. We want to establish that a squared must be 3b. We want to establish that a squared must be 3b. If z1, z2, z3, where z3 is 0, constitute an equilateral triangle, are the vertices of an equilateral triangle, we want to show that a squared is 3b. Hey, one thing, if z1 and z2 are the roots of this, then what is z1 plus z2? Minus a. What is z1, z2? b. Yes or no? Now, did I tell you in my last class, if z1, z2, z3 constitute the vertices of an equilateral triangle, then z1 squared plus z2 squared plus z3 squared minus z1, z2 minus z2, z3 minus z1, z2 must be 0. Z1, z3 must be 0, right? Z3 is anyway 0, so this will vanish, this will vanish, this will vanish, right? And z1 squared plus z2 squared I can write as z1 plus z2 whole squared minus twice z1 z2 minus twice z1 z2 minus z1 z2, so that makes it minus thrice z1 z2 equal to 0, right? Hey, but z1 plus z2 is minus a, so this will become a squared minus 3b equal to 0, right? Or a squared equal to 3b. Right? A is a point on the argand plane. O is the origin and OA is the diameter of a certain circle. O is the origin and OA is the diameter of a certain circle. OA is the diameter of a certain circle. So let's say this is a semicircle that I draw, right? And 2 points on this circle are chosen, B and C, such that angle AOB is theta, angle BOC is also theta. Clear? And ABC have position vectors z1, z2, z3. ABC have position vectors z1, z2, z3. We want to show that z2 squared cos 2 theta is z1, z3 cos square theta. z2 squared cos 2 theta is z1, z3 cos square theta. Now, we reformulate the problem, right? We address a problem in which instead of doing this, we deal with z2 squared by z1, z3. We want to show is cos square theta divided by cos 2 theta. And let's deal with this problem instead. We show that z2 squared by z1, z3 is cos square theta by cos 2 theta. Let's deal with this instead. All right. Now, this z2 squared by z1, z3 is like z2 by z1 into z2 by z3, right? So instead of dealing with this, let's deal with two different things, z2 by z1 into z2 by z3. Let's deal with these two factors, z2 by z1 and 2 by Z3. Okay. Now, Z2 by Z1, for example, will have a modulus. What's the modulus of Z2? OB by OA. So, modulus of this complex number is OB by OA, yes or no? That's the modulus of this complex number into e power I. Theta would be the argument of this complex number. The argument of this complex number is the amount by which you must rotate the denominator vector so that it coincides with the numerator vector. Now this is the origin. So this vector is Z1 minus 0. This vector is Z2 minus 0 because this is the origin. So amount by which you must rotate Z1 minus 0 so that it coincides with Z2 minus 0 is theta. So this is e power I theta. So Z2 by Z1 is OB by OA e power I theta. Right? Now Z2 by Z3. Z2 by Z3. This is Z3. Right? Z2 by Z3 will have a modulus. That will be modulus of Z2 by modulus of Z3. Modulus of Z2 would be OB. Modulus of Z3 would be OC. So OB by OC e power I. Argument. Argument means amount by which you must rotate Z3 so that it coincides with Z2 minus theta. This is Z3. You must rotate it clockwise so that it coincides with theta. So argument would be minus theta. Very good. Very good. Yes or no? Does it make sense? And let's multiply them out because we need to find the value of Z2 squared by Z1 Z3. Let's multiply them out. Then that will become minus theta and this will become theta. Not matter. Not at all. In the given expression, if you replace theta by minus theta, nothing will change. Cos 2 of minus theta would be cos 2 theta. Cos square theta, replace theta by minus theta, nothing will change, isn't it? Huh? So if I multiply this and this, then I end up getting Z2 squared by Z1 Z3. And e power minus I theta into e power I theta would be 1, will be OB squared divided by OA into OC. Yes or no? Hey, what is this angle? 90 degrees angle in a semicircle. So do you realize the length OB would be OA cos theta? OB would be OA cos theta? Yes or no? So this is like OA squared cos square theta divided by OA. Now OC, what would OC be? Again this is 90 degrees and this is 2 theta. So OC would be OA cos 2 theta because this is 90 degrees once again. OC would be OA cos 2 theta. Which is like cos square theta by cos 2 theta. Yes or no? All's good? Now, G, 1, 2, 3, etc. I've already dealt with. Right? Remember just a little while ago? G, part 1, part 2, part 3. Let me deal with part 4. Let me deal with part 4. Alright. We want to find the locus of Z such that argument of Z minus 1 by Z plus 1 is pi by 4. Clear? Minus 1 and plus 1 are two complex numbers. Right? Say this point is A, which is complex number minus 1. This point is B with complex number position vector plus 1. This is Z1 equal to minus 1. This is Z2 equal to plus 1. Right? Minus 1 and plus 1. And there is a point P, moving point P, Z. Z. Now, do you realize that this vector, if this is P, then this vector would be Z plus 1, yes or no? This will be the direction of Z plus 1, Z minus 1. And this vector would be Z minus 1, yes or no? This vector would be Z minus 1. Now, what does this say? The amount by which you must rotate the denominator vector Z plus 1 so that it coincides with the numerator vector Z minus 1 is pi by 4, yes or no? That means this angle must be pi by 4. Right? Yes or no? Such is P. A and B are two fixed points and P moves like this such that it maintains this angle as pi by 4. Which means, do you realize that there is a circle with a chord AB, A is minus 1 and B is plus 1, and it has a major segment and it has a minor segment, and on this circle AB subtends pi by 4 at any point on the major segment. So that means P could lie anywhere on this major segment and this angle will be pi by 4. If this is pi by 4, this is also pi by 4. Right? So P describes the major segment of the circle, not the minor segment. Not the minor segment. Why? See, if Z was a point here on the minor segment, then this would be Z plus 1 and this would be Z minus 1. Then the amount by which you must realize that if this is pi by 4, this would be 3 pi by 4. The amount by which you must rotate Z plus 1 so that it coincides with Z minus 1 would be minus 3 pi by 4. Then it wouldn't have been pi by 4. So Z does not describe the entire circle. It describes only major arc of the circle. Because on the minor arc, if Z were to be there, then this argument would have been minus 3 pi by 4. Yes or no? So this is part of a circle. This is part of if you proceeded by saying Z is x plus iy and plugged in values, you will get the full circle. You will get the equation of the full circle. Therefore, it will hide from you the fact that it's not the full circle that Z describes. It describes only the major arc of the circle. On the minor arc of the circle, this argument will not be pi by 4. Clear? Let's move. Because it's a multiple valued function, that argument, that is why. So you can't take argument Z as y by x all the time, right? It has limitations. That's why that redundancy comes in. H. We want to find a complex number Z having least positive argument such that mod Z minus 5i is less than or equal to 3. Right? We want to find, see, Z is a complex number like this. There are several Z's that satisfy this condition. Of the several Z's that satisfy this condition, we want to find that Z which has the least positive argument. Now, first of all, geometrically, mod Z minus 5i equal to 3 is what? A circle with center 5i and radius 3. Yes or no? Z is such that its distance from 5i remains 3. So this is a circle centered at 5i and radius 3. Right? If I said less than 3, that means distance of Z from 5i is less than 3. Then it will represent points inside the circle. Right? If I said mod Z minus 5i greater than 3, that means distance of Z from 5i greater than 3, it will be points outside the circle. So mod Z minus 5i less than or equal to 3 are points on or inside the circle with center 5i and radius 3. Yes or no? Right? Now, Hey, what date is today? 25th. Now, this is 5i. Will be a point on the y-axis. This is a circle of radius 3. The locus of z would be this entire region, which is also points on this circle with center 5i and radius 3. Yes or no? Clear? Of all the z's that lie on the circle and inside the circle, which one has the least positive argument? Do you realize that if from O I draw a tangent, if I draw a tangent, and this point is P, which is z, then theta would be the argument of this z. Now any other point would have an argument greater than theta. Yes or no? Any point in this region would have an argument greater than theta. Yes or no? That means this point P, the point of tangency from O, would have least positive argument, How about it? That means I need to locate this z. Do you all understand that? Now, this is 3 units. This length is 5 units. So OP would be 4 units, Pythagoras theorem. OP would be 4 units, 3 units, this is 5 units. How about it? Right? And if this is theta, this is 90 degrees, this will also be theta. Do you then realize OP is 4 units? Do you then realize that cos theta would be 3 by 5? Cos theta would be 3 divided by 5, and sin theta would be 4 by 5. Yes or no? Then this length would be OP cos theta, the x coordinate of P. This length would be OP sin theta, right? So Z would have its x coordinate as OP cos theta plus I OP sin theta, IY, right? OP of course is 4 into cos theta, which is 3 by 5, plus I into 4 by 5. This would be Z. Z would have coordinates 12 by 5 and 16 by 5 would be the coordinates of Z. Yes or no? Make sense? If it was an obtuse angle, then it will be on the major arc. It's an acute angle, it will be on the minor arc. That's the point. On the major arc, the angle will be acute. On the minor arc, it will be obtuse. That's the rule of the game, isn't it? No, but how can it lie inside the circle? It will always be point on a circle. The circle will be different. It will always lie on the circle only. It will never be a point inside the circle. Mod Z equal to K is what? Is a circle, points on a circle with center, origin and radius K. Various Z's lying on a circle with center, origin and radius K. We want to find the locus of K by Z. That means, essentially these are various z's whose distance from the origin is k. Mod z is k. These are various z's whose distance from the origin is k. Right? For every such z, I can construct a complex number k by z. I want to find the locus of these k by z's. For every such z lying on this circle, I can construct a complex number k by z. I want to find the locus of these k by z's. You know what I'm saying? Okay. That means I want to find the locus of z1. I want to find the locus of z1. Right? I want to find the locus of z1. Hey, if I took the modulus of both sides, then mod z1 is k is a positive number, mod k by mod z. Mod z is k. So this is 1. That means mod z1 is 1 means what? z1 lies on a circle centered at the origin and radius 1. So the locus of z1s will be a circle with center at the origin and radius 1. Got me? All's good? J. Z is such that mod z minus 2 minus 2i is 1. Several z's satisfy this. Now, this represents what? A circle with center 2 minus 2i. That means point 2 comma minus 2 and radius 1. Right? Each of these z's will have a certain modulus. Each of these z's satisfying this condition will have a certain modulus. We want to find the largest mod z and the smallest mod z of all the z's that satisfy this condition. Hey, let me do it geometrically. This is a circle with center 2 comma minus 2, with center 2 comma minus 2, 2 minus 2i is 2 comma minus 2, and radius 1, yes or no? Right? Yes or no? All z's lie on this. All z's satisfying this condition, circle with center. So the z's lie on this. Of these z's, we want to find the least mod z and largest mod z. Mod z is what? Distance of z from the origin. Mod z is least means that z is closest to the origin. Mod z is largest means that z is farthest from the origin. Do you realize that of all the z's lying on this, you draw a diameter like this, then this z would have this as the mod z and this would be the smallest mod z, and this z would have largest mod z, right? So suppose this is OA, this is OB. OA is therefore least mod z, which would be, do you realize that this length is 2 root 2? Distance of 0, 0 from 2 comma minus 2 is 2 root 2 minus 1 unit. The radius of the circle will give me OA. OA is least mod z, yes or no? So which would be 2 root 2 minus 1. And say z prime, B is z prime. OB is largest mod z, right? Which would be 2 root 2 plus 1. Right? Now, both z and z prime realize that this is 2 units, this is also 2 units. So this angle is minus pi by 4. What's the argument of z? Minus pi by 4. What's the argument of z prime? Minus pi by 4. So can I write z as this z, that means for A, the point A, the z as e power minus I pi by 4 into 2 root 2 minus 1. So that's going to be 2 root 2 minus 1 e power minus I pi by 4. That represents this z, and this z prime, that is for B. Z prime is 2 root 2 minus 1 e power, plus 1 e power minus I pi by 4. Yes or no? K. Now there is a moving point Z such that argument Z is pi by 6. And there is another Z, set of Z's that satisfy this condition. Z minus 2 root 3 I equals K. We want this curve and that curve to intersect. Now, first of all, what does this represent? Circle with center 2 root 3 I and radius K. Let me draw the locus of the second curve. This is 2 root 3 I, this point is 2 root 3 I and radius K, Okay. This is a straight line passing through the origin in the first quadrant making an angle pi by 6. We want this, so this, all points here would be argument Z equal to pi by 6. This is pi by 6, right? Now, what I do is, I drop a perpendicular from the center C of this, I drop a perpendicular, right? Say this point is D, this point is D. This is pi by 6, this will also be pi by 6, this angle OCD would be also pi by 6, yes or no? Right, this is 90 degrees. Then, what is CD? What is CD? CD is OC cos pi by 6. OC cos pi by 6, yes or no? OC is 2 root 3. Cos 30 degrees means root 3 by 2, which is 3. And in order that the two intersect, this length should not exceed the radius of the circle. This length should not exceed the radius of the circle. So CD must be less than or equal to the radius K of the circle. So K must be greater than or equal to 3. Yes or no? K must therefore be greater than or equal to 3. Is that okay? Let's look at L then. Let's look at L. Problem number L is about mod of Z by mod Z minus 1 less than or equal to mod of arg Z. Right? This is what we need to establish. Now, it's okay. Let's do it geometrically. All right. First of all, locate a complex number Z anywhere. That means OP would be the vector Z. OP would be the vector Z. Now Z by mod Z is what? A unit vector in the direction of Z. A vector Z divided by mod Z is a unit vector in the direction of Z. That means Z by mod Z is located on OP 1 unit away from O. Z by mod Z, Z1, which is Z by mod Z, is a vector such that mod Z1 is 1, because mod Z1 is mod Z by mod Z, which is 1. So it's 1 unit away from the origin, and the direction of Z1 and the direction of Z is the same. Isn't it? This is the direction of Z. This is the direction of z1, and z1 is a unit vector in the direction of z, isn't it? I still don't understand why you're not thinking of it exactly like vectors. Vector divided by its magnitude is a unit vector in the direction of z, right? 1 by mod z is a scalar k, right? So this is the vector z. Then there is a point q. There is a point q, and the position vector of q is going to be z by mod z is going to be the position vector of q, where OQ is 1 unit. OQ is 1 unit. How about it? All's good. Now, z by mod z. Z by mod z is the vector OQ. Z by mod z is the vector OQ. Z by mod z minus 1. 1 is a complex number lying on the real axis, x-axis, right? So draw an arc OQ 1 unit. Then this point would be R, the complex number 1. Yes or no? Q and R lie on the same circle centered at O, 1 unit away from O, right? Then do you realize this has position vector z by mod z, this has position vector 1. Therefore, z by mod z minus 1 is the chord RQ. The vector RQ is z by mod z minus 1 is the vector RQ, and mod of this is the chord RQ. The chord QR is this? Yes or no? Now, theta could have been positive or negative, but this, if it is positive, then it should be looked upon as modulus of argument z. Theta could be looked upon as modulus of argument z. The radius of this circle is 1 unit. This is the chord QR. What about the arc QR? R theta? 1 into theta? 1 into theta? One into theta? S is R theta? Hey, very clearly, chord length will be less than or equal to arc length. Chord length will be less than or equal to arc length. This is what it is. This is QR less than or equal to arc QR. Yes or no? Which is a true statement. Chord length less than or equal to arc length. This is the statement of the problem, which is true. Sounds fair? Shall we then proceed to the next problem? That is actually very easy. You can take z as r e power I theta, that is r cos theta plus I sin theta. That's actually the most, where mod arc z would be theta. So essentially it will boil down to sin theta less than or equal to theta kind of a thing is what it will get reduced to if you work around that. That's actually the easier portion. I would rather have preferred the geometrical. You can, if you don't get it, then show it to me. Just take z is r e power I theta, take the modulus of that complex number. So this will be simply e power I theta, isn't it? Minus 1, etc. That will be an easier way to do this. That will be easier to handle. M. It's given mod of z1 less than 1, that's z1, and mod of z1 minus z2 divided by 1 minus z1 bar z2 is less than 1, that's given. We need to prove that mod z2 is less than 1. We need to show that mod z2 is less than 1. That's what we need to establish. See, this is less than this, means square of this would be less than this. That means mod z1 minus z2 whole square would be less than mod 1 minus z1 bar z2 square. Right? Now, have I given you the result for mod z1 minus z2 whole square? Mod z1 squared plus mod z2 squared minus twice real z1, z2 bar, etc. I have given that result, isn't it? So, this is like mod z1 squared plus mod z2 squared minus twice real z1, z2 bar, or let me take it z1 bar z2 so that it matches with this. It will not make a difference, right? Z1 bar, isn't it? Real part of this or real part of its conjugate is going to be the same. Less than or equal to 1 plus mod of this squared. Mod of z1 bar squared would be mod z1 squared into mod z2 squared. Minus twice real this into bar of this, right? So that I get the same thing. Twice this into bar of 1 will be 1 only. Twice real z1 bar z2. Conveniently, this goes into oblivion. Right? And now you transpose everything on one side, So, what you can get is 1 minus mod z1 squared minus mod z2 squared plus mod z1 squared into mod z2 squared less than 0. Greater than 0, which would mean 1 minus mod z1 squared into 1 minus mod z2 squared greater than 0. Factorizing this, yes or no? But mod z1 squared is less than 1, so this is greater than 0. So for this to be greater than 0, mod z2 squared must be less than 1. And if mod z2 squared is less than 1, mod z2 is less than 1. Yes or no? So this will mean problem n, it's given cos theta plus I sin theta x equal to cos theta plus I sin theta is a root of a naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus an equal to 0. That's given. Where a naught, a1, an are all real numbers, a naught is not 0. All right. We want to establish a naught plus a1 cos 2 theta cos theta plus a2 cos 2 theta plus an cos n theta is 0. Right. Now, see, if x is a root, that means x satisfies this. But if I plug in the value of x as cos theta plus I sin theta, it will give me a naught cos theta plus I sin theta whole to power n. That means cos n theta plus I sin n theta. That means a naught cos n theta we'll get. But we don't need a naught cos n theta here. We need a n cos n theta. That means we need to do some jugglery here to produce that, right? Now realize that if cos theta plus I sin theta is a root, then cos theta minus I sin theta will also be a root. But cos theta minus I sin theta, do you realize, is 1 by x? If this is x, then that's 1 by x. Yes or no? So if x is a root, cos theta minus I sin theta, which turns out to be 1 by x, will also be a root. So I can replace x by 1 by x. Right? 1 by x is a root. So which means a naught 1 by x to power n plus a1 1 by x to power n minus 1 plus a2 1 by x to power n minus 2 plus an must be 0. Right? Which means a naught plus a1x plus a2x squared plus anx power n must be 0. Now you can plug in x equal to cos theta plus I sin theta. So which means a naught plus a1 cos theta plus I sin theta plus a2 cos theta plus I sin theta whole squared, which will be cos 2 theta plus I sin 2 theta. Plus a3 x cubed means cos theta plus I sin theta whole cube, which is cos 3 theta plus I sin 3 theta. Going this way, plus an cos n theta plus I sin n theta must be 0. Equate real and imaginary part. So if you equate the real part on the left hand side, a naught plus a1 cos theta plus a2 cos 2 theta plus a3 cos theta plus an cos n theta, that must be 0, which will produce the required result given as such. Is that fine? I have established in the class for a polynomial of degree n, complex roots occur in pairs. I have told you that if f of z is a plus ib, f of z bar is going to be a minus ib, and so on and so forth. So z and z bar, if z is f of z is 0, f of z bar will be 0, and so on and so forth. Clear? So I'm not getting into this. Let me look at the next one. Can I wipe this off? Is this understood by all? One into 2 minus omega into 2 minus omega squared plus 2 into 3 minus omega into 3 minus omega squared plus n minus 1 into n minus omega into n minus omega squared. We need to find the value of this, right? So do you realize that this is actually summation of terms of the kind r minus 1 into r minus omega into r minus omega squared, where r ranges from 2 to n minus 1, r ranges from 2 to n minus 1, 2 to n, r ranges from 2 to n, yes or no? Now just to make life a little convenient in terms of computation, even if I took r equal to 1 to n, will it make any difference? Because r equal to 1 will anyways produce 0. So let me start from 1 to n so that you know some of the squares of the first 10 natural numbers, some of the cubes, etc., all of that could be dealt with greater ease, right? And will not make a difference in the summation. So let me start from 1 to n. What is this? What is this? X cube minus 1, did I tell you how to factorize? Is it not r cube minus 1? See, these are cube roots of unity, 1 omega and omega squared. So is this not the factors of r cube minus 1? R cube minus 1 has factors r minus 1, r minus omega and r minus omega squared. So r cube, isn't it? Because r cube minus 1 has roots 1 omega and omega squared. So r minus 1 must be a factor of r cube minus 1. R minus omega must be a factor of r cube minus 1. And r minus omega squared must be a factor of r cube minus 1. So you don't have to bother too much about this. This is simply summation of r cubed minus 1 r equal to 1 to n, which is summation r cubed minus summation 1 r equal to 1 to n. Sum of the cubes of the first 10 natural numbers, n into n plus 1 by 2 whole squared, and this will be n. Clear? The maximum value of mod z is what we need to find. We want to find maximum mod z given that mod of z plus 2 by z is 2. Given that mod of z plus 2 by z is 2. So what I do is, let me start by expressing mod z in terms of this condition. Now mod z can be written as mod of z plus 2 by z plus minus 2 by z. Right? This is z1, z2. Mod of z1 plus z2 it will be less than or equal to mod z1 plus mod z2, right? The triangle inequality, mod of z1 plus z2 is less than or equal to mod z1 plus mod z2. So this will be less than or equal to mod of this. Mod of this is actually 2. And mod of this is 2 by mod z. Mod of z1 plus z2 less than or equal to mod of this, which is given to be 2, plus mod of this, which is 2 by mod z. Right? So we end up getting mod z less than or equal to 2 plus 2 by mod z, or we get mod z squared minus 2 mod z minus 2 less than or equal to 0. See, mod z squared minus 2 mod z minus 2 less than or equal to 0. Let me just to factorize this, let me find out the roots of t squared minus 2t minus 2 equal to 0, so that I can factorize this. So this has roots 2 plus minus root 4 plus 8 12 divided by 2, which is 1 plus minus root 3 will be the roots of this. So that means if I have to factorize this, it's going to be mod of z minus 1 plus root 3 into mod of z minus 1 minus root 3 less than or equal to 0. Now wavy curve method in mod z, this node 1 minus root 3, which is negative, this node 1 plus root 3. This is the sign of mod z. However, this is negative in this interval. This is negative in this interval, yes or no? Mod z this product will be negative in this interval, yes or no? Right? Therefore, in this interval, this then is the largest value of mod z. Yes or no? This is the largest value of mod z. If this condition has to be true, that means mod z will be confined to this region. And in this region, largest value of mod z would be this. In fact, what really happens is, since mod z is never at negative, 0 is a value between this and this. So mod z will not have any value in 1 minus root 3 to 0. But that does not matter, isn't it? The maximum value of mod z will be 1 plus root 3, isn't it? Right? So mod z max in this proposed interval is 1 plus root 3. Is that fair? It is not, because mod z never becomes equal to 1 minus root 3. Mod z will take values only from this to this. That's exactly what I was saying. Right now? R. What's given is alpha is given to be an nth root of unity. If alpha is an nth root of unity, alpha to power n must be 1, right? We need to find the value of s given to be 1 plus 2 alpha plus 3 alpha squared plus n alpha to power n minus 1. We want to find the value of this. It's an arithmetico-geometric progression. 1, 2, 3 n in arithmetic progression, alpha squared in GP. Multiply by alpha and subtract the two equations. Multiply by alpha. Shift the whole thing 1 unit to the right. Alpha plus 2 alpha squared plus n minus 1 alpha to power n minus 1 plus n alpha to power n. And now I carry out a subtraction. So s into 1 minus alpha equals 1 plus alpha squared plus alpha to power n minus 1 minus n alpha to power n. Hey, the n roots of unity are in GP. So if alpha is a root, alpha squared, alpha cubed, alpha to power n minus 1 are all n roots of unity. And this is 1 is also an n root of unity. This is sum of all n roots of unity, which is 0. So this will be 0. And this alpha to power n is 1. So you'll be left with minus n on the right hand side. So this is simply minus n, which means s then turns out to be minus n by 1 minus alpha. S. Mod z1 is mod z2 is mod z3, and z1 plus z2 plus z3 is 0. We want to show that z1, z2, z3 constitute vertices of an equilateral triangle. Now, if mod z1 is mod z2 is mod z3, that means distance of z1 from the origin is distance of z2 from the origin is distance of z3 from the origin. That means z1, z2, z3 lie on a circle centered at the origin. That means their circumcenter is the origin. Yes or no? See, if this is the origin, this is z1, this is z2, this is z3, and they are equidistant from the origin, right? So that means the circumcenter of triangle formed out of z1, z2, z3 is the origin, right? Circumcenter of this triangle is the origin. Now, if z1 plus z2 plus z3 is 0, z1 plus z2 plus z3 by 3 is 0. But what does this give me? The position vector of the centroid of triangle ABC. That means the centroid is also the origin. That means the centroid and the circumcenter coincide. Triangle therefore must be equilateral. If the circumcenter and the centroid coincide, the triangle must be equilateral. Isn't it? Clear, no? Proceed. Z1, Z2, Z3 are complex numbers such that 2 by Z1 is 1 by Z2 plus 1 by Z3. We want to show that the quadrilateral formed out of A, which is Z1, B, which is Z2, C, which is Z3, and D, which is say Z4, which is the origin, is cyclic. We want to show that this quadrilateral is cyclic. Now, very clearly, if this is a cyclic quadrilateral, then this angle must be the same as this angle. Angles in the same segment? Sorry? So if they lie on the same circle, it's as if showing that this is a cyclic quadrilateral. Right then, now to obtain this angle and this angle must be equal. Now if you recall, to obtain this angle theta, that must be argument of Z3 minus Z1 divided by Z0 minus Z1. Yes or no? Right? The amount by which you must rotate 0 minus Z1 so that it coincides with Z3 minus Z1 must be theta. Right? And the same theta I can obtain by rotating 0 minus Z2 so that it coincides with Z3 minus Z2. So that must be the same as argument of the final vector Z3 minus Z2 divided by 0 minus Z2. Right? If they have to be cyclic, right? So for this to hold good, then argument A is argument B. So argument A minus argument B is 0. So argument A divided by B must be 0. So A by B must be real. Right? So this must be argument of Z3 minus Z1 divided by minus Z1 Z3 minus Z2 divided by minus Z2. This must be 0. What do you say? This minus, of course, now. That means we need to show that this is a real number. Equivalently, we want to show that this is a real number. Given this condition, if I can show that this is real, then the problem is taken care of. Right? That means Z3 minus Z1 divided by Z1 into Z2 divided by Z3 minus Z2. We want to show that this is real. We want to show that this is real. Let's check this, because if this turns out to be real, then argument of this will be 0. What's the algebra that we need to take care of? This. We have to use this to show that this is a real number, right? Now, of course, different people will do it differently. Z1, I'll just use brute force 2z2 z3 by z2 plus z3, right? Yes or no? So this z1 I replace by 2z2 z3 by z2 plus z3, right? Minus z1, which is 2 z2 z3 by z2 plus z3 to z2 z3 by z2 plus z3 into z2 divided by z3 minus z2. This is what we need to deal with, right? This will shift in the numerator, and realize that, you know, I could cancel this z3 with this z3. This z2 would get cancelled with this z2. This z3 is 1, this z3 is 1, and this goes away. Yes or no? Right? And then it's as simple as z2 plus z3 minus 2z2 divided by 2 into 1 by z3 minus z2 plus z3, z2 plus z3. So which is like z3 minus z2 divided by 2 into 1 by z3 minus z2, which is a real number half. Which is a real number half. So argument of this will be 0, and all other conditions would hold good as expected. Right? Didn't understand? What? What did you not understand? Huh? There was a z3 here, which I cancelled with this. Alpha, beta, gamma are the cube roots of P. Are the cube roots of P. We need to find the value of alpha x plus beta y plus gamma z divided by beta x plus gamma y plus alpha z. We need to find the value of this, given that alpha, beta, gamma are cube roots of unity. Cube roots of P. Now, see, if I have to think of cube root of P, it's like 1 to power 1/3 into P to power 1/3. Yes or no? This would be the cube root of P. Right? 1 to power 1/3 will have 3 values, 1, omega and omega squared. Right? So 1 cube root of P, for example, could be, if I take 1 to power 1/3 as 1, then it will be P to power 1/3, 1 cube root of unity. The other cube root of unity is going to be, I take 1 to power 1/3 as omega, then the other cube root of P is going to be omega into P to power 1/3. Right? If I take 1 to power 1/3 as omega squared, then the third cube root of unity is going to be omega squared P to power 1/3. These are the 3 cube roots of unity. Yes or no? Right? Now, I plug in alpha, beta, gamma given by that, and it could be yet another permutation of this. I mean, this could be alpha, this could be beta, this could be gamma. Isn't it? But let me look at this. So when I plug in alpha, beta, gamma in the numerator and denominator, P to power 1/3 will get cancelled. Right? So what we'll then be left with, if p to power 1/3 gets cancelled on plugging alpha, beta, gamma, we end up getting x plus omega y plus omega squared z, omega x plus omega squared y plus z. This is what we'll get. Yes or no? Do you realize that on multiplying this by omega, we get the denominator omega x, omega squared y, omega cube, which is 1 z. Yes or no? So is this not 1 by omega? But 1 by omega is actually omega squared, because this one is omega cubed by omega is omega squared. And if you take some other permutation, you would get another value of this, which is omega. That means, what would happen is the numerator will become omega times the denominator. If you took some other permutation, then the numerator will become omega times the denominator. So the other value of this could have been omega by taking a different permutation of alpha, beta, gamma. Clear? I tried to make this sheet small, just giving you one problem in this sheet. The others are only parts, so there is just one problem sheet this time. Oh, two kya? Oh, sorry, made a mistake. Long sheet. Huh? Because it got over at Z, I didn't want to make it sections like you have in school. Z1, Z2, Z3. You have like Z, sections till Z?
Next year, but there is hope. 23.
They'll reduce?
No. 23.
Oh, 23 more?
No. Sir, there's hope for more sections. Right now we have 23.
Way to go, man. Okay. We need to show that all roots of z power n cos theta maybe theta naught, you can say, z power n minus 1 cos theta 1, z power n minus 2 cos theta 2 plus cos theta n, where these thetas are all real numbers equal to 2. All the roots of this lie outside the circle mod z equal to half. Mod z equal to half is a circle centered at the origin and radius half. All points outside this circle would be z such that mod z greater than half. This is what we need to show, right? Clear? Now, if this is this, then mod of this is 2. Mod of this is also 2. Mod of z1 plus z2 plus z3 plus zn would be less than or equal to mod z1 plus mod z2 plus mod z3 plus mod zn. Yes or no? So this is less than or equal to this expression E, modulus of this would be less than or equal to mod of this, which is mod z power n cos theta naught plus mod z power n minus 1 cos theta 1 plus mod cos theta n. Yes or no? The left hand side is 2, of course. Mod of this is this. So mod of the summation would be less than or equal to sum of the mods, right? So this, of course, you could write as mod z power n into mod cos theta naught, mod z power n minus 1 into mod cos theta 1, etc. Modulus of the product will be product of the moduli. But mod cos theta naught, mod cos theta 1, mod cos theta n are all less than 1. So this expression will be less than or equal to mod z power n plus mod z power n minus 1 plus mod z power n minus 2 plus 1, right? But mod of z power n would be mod z whole to power n. Mod z power n minus 1 would be mod z power n minus 1. Right? Mod and these powers are interchangeable entities, etc. Right? Now this is like 1 plus, the term before this would have been mod z, 1 plus mod z squared plus etc. etc. This would be less than a series with infinite number of terms starting with 1 plus mod z squared plus etc. Right? Yes or no? 1 plus t squared plus t to power n will always be less than or equal to 1 plus t squared up to infinity. This has the same terms as this and more, isn't it? So this will have a greater summation. None of the terms is non-negative here. More number of terms, the merrier. Right? Yes or no? I hope all of you understand this. Right? Now, see, if you assume mod z greater than 1, you have nothing to prove. Then mod z will also be greater than half. Right? Therefore, you have to assume that mod z less than 1. Mod z less than 1 means this is an infinite GP series with common ratio mod z less than 1. Okay, now one thing, this time the equality will go into oblivion. This will not be equal to this. This will always be strictly less than this. Yes or no? From here to here, the equality will dissolve. This certainly is greater than this, right? So then we have 2 less than 1 by 1 minus r. So, yes or no? And mod z is less than 1, we have assumed. So mod z minus 1 is greater than 0, so I can multiply throughout by 1 minus mod z and not change the direction of the inequality. Therefore, mod z is greater than 1 minus half. Therefore, z must lie outside a circle whose center is 0 and radius is half. This is what we set out to prove. Number y. Such that mod z1 minus 1 is mod z2 minus 1 is mod z3 minus 1, an argument of z3 minus z1 divided by z2 minus z1 is pi by 6. Right? We need to show what was that extremely melodious? Somebody's phone in action? Whose was that? My God, I would have dozed away to glory had it been acting for another minute or so. No, I'm only complimenting you for carrying such a melodious ringtone. Sit down. All right. Let's look at geometrically what it all means. Right? See, this means distance of z1 from 1 is distance of z2 from 1 is distance of z3 from 1. That means z1, z2, z3 are equidistant from the complex number z naught equal to 1. That means a triangle constituted out of z1, z2, z3 has its circumcenter equal to 1. The circumcenter of the triangle formed by z1, z2, z3 is 1, right? This is Z naught equal to 1. Right? Now, let's look at this. What is Z3 minus Z1? Z3 minus Z1 is this vector. What is Z2 minus Z1? Is this vector. The amount by which you must rotate the denominator vector so that it coincides with this numerator vector is 30 degrees, pi by 6. Now, if that is pi by 6, what is this? Angle at the center is twice the angle on the circumference. So this is pi by 3. Clear? This is R, this is R, this is 60 degrees. This is an equilateral triangle. This is an equilateral triangle, yes or no? Right? And if this is an equilateral triangle Z0, Z2, Z3, then this square plus this square plus this square minus this into this minus this into this minus this into this must be 0. That's a property for an equilateral triangle. So can I say Z0 squared plus Z0 is 1 plus Z2 squared plus Z3 squared minus Z0 Z3 minus Z2 Z3 minus Z3 Z0 Z2 Z0 must be 0, which will actually be this result only jumbled up, which will be this jumbled up. This put Z0 equal to 1 and you will get this. All right, which is all. Time to proceed. Can I wipe this off? Z1, Z2, Z3 are complex numbers. Whereas PQR are real numbers. It's given P by mod Z2 minus Z3 equals Q by mod Z3 minus Z1 equals R by mod Z1 minus Z2. We need to show that P squared by Z2 minus Z3 plus Q squared by Z3 minus Z1, it must be Z1. It's written, yeah, that's a mistake, I'm sure. Plus R squared by Z1 minus Z2 is 0. That's what we need to show. Okay, so we need to bring in P squared, Q squared, R squared from somewhere first, right? So we square these. Each is say K. Mod Z squared is ZZ bar. So then each of these mod Z squared I write as ZZ bar. So P squared by Z2 minus Z3 into Z2 bar minus Z3 bar equals Q squared by Z3 minus Z1 into Z3 bar minus Z1 bar equals R squared by Z1 minus Z2 into Z1 bar minus Z2 bar. Each is K. So P squared by Z2 minus Z3, P squared by Z2 minus Z3 would be K into this. Q squared by Z3 minus Z1 would be K into Z3 bar minus Z1 bar. R square by Z1 minus Z2 is going to be K into Z1 bar minus Z2 bar. Yes or no? So plugging in, yes. So this is going to be P K into z2 bar minus z3 bar, z3 bar minus z1 bar, right, z1 bar minus z2 bar, which is evidently 0 as was required. Shall we proceed? So we've just finished one problem. Yeah, in 2 days, imagine. 2a. Z lies on the curve mod z minus 1 plus I equals 1. Which is what? A circle with center minus 1 plus I and radius 1, right? For every z lying on the circle, we create another complex number t. For every z that lies on this complex number, we create a complex number t, which is z plus I by 1 minus I. We create a complex number t, which is z plus I by 1 minus I. So for every z, there is a t created. And now these t's are put up. We want to find the locus of these t's. For different z's that belong to this, we want to find the different t's that are obtained from this transformation. This is the transformation from z to t. We want to find the locus of t. So what I do is, see, very clearly z is t into 1 minus I minus I. So from z domain to t domain, this is the transformation. I replace that z by this t, right? So this is mod of t into 1 minus I minus I minus minus 1 plus I equal to 1. Z to t, which is mod of t into 1 minus I plus 1 minus 2I equal to 1. I take mod 1 minus I common, mod of t minus 2I minus 1 by 1 minus I equal to 1. But mod of 1 minus I is root 2. Mod of 1 minus I is root 2. So this gives me mod of t minus 2I minus 1 by 1 minus I as 1 by root 2. That means t describes a circle with radius 1 by root 2 and with center t naught equal to 2I minus 1 by 1 minus I. T describes a circle with center t naught equal to this and radius 1 by root 2. That's the locus of t. In fact, let me tell you, every time you have something like this, say mod of z minus z naught equal to r, say, and you create a linear transformation, that means you say t equal to az plus b by bcz plus d. If this transformation you create, right, then the locus of t will always be a circle, or rather say c plus d. If you create this linear transformation kind of a thing, then the locus of t will always be a circle for this linear transformation from z to t. You can check that out. Okay. Okay, let's look at the next one. Mod z is 1, we need to find the value of 1 plus z by 1 plus z bar. Mod z is 1 means what? ZZ bar is 1, mod z squared would be 1, so ZZ bar would be 1, right? And I can replace this z bar by 1 by z. So this will simply be z, right? And it's also going to be 1 by z bar if you like, because ZZ bar is 1, so it's also going to be 1 by z bar, right? Sounds good? K greater than 0. Mod z is, mod omega is k. If alpha is z minus omega bar divided by k squared plus z omega bar, we need to find the value, real value of alpha. We need to find the real value of alpha. That's what we need to be doing. Clear? Real value of a complex number is half of alpha plus alpha bar. Yes or no? Isn't it? So let me find twice real value of alpha, which is alpha plus alpha bar. How about it? Twice real alpha will be alpha plus alpha bar. Alpha is this. Plus bar of this, right, which is z bar minus omega. K is a real number, k squared would be a real number, its bar will be the same. So z bar omega. Is it not? Now, mod z is mod omega is k. So mod z squared is mod omega squared is k squared, right? So zz bar would be omega omega bar is k squared. Now what I do is, in this expression, this z bar I replace by k squared by z, this omega I replace by k squared by omega bar, and z bar once again by k squared by z, omega by k squared by omega bar. I do this so that it will match with this expression, the terms. So then z minus omega bar divided by k squared plus z omega bar plus z bar, which is k squared by z, minus k squared by omega bar, right? Omega would be k squared by omega bar divided by k squared plus, this will become k to power 4 by z into omega bar. See, this z bar I wrote as k squared by z, this omega bar I wrote as k squared by omega, I wrote as k squared by omega bar. This is what I did here. I hope you realize whatever I have done here, right? Which is z minus omega bar divided by k squared plus z omega bar and this will come here, this k squared would get cancelled, this will become k squared, right? So then this would be omega bar minus z divided by z omega bar, or rather let me place it there right away, z omega bar plus k squared. 0. Then you are a hero. So real alpha is 0. So alpha must be purely imaginary. Alpha must be purely imaginary. Argument of alpha could be plus pi by 2 or minus pi by 2. Z1, Z2 are two complex numbers such that mod Z1 is mod Z2 plus mod Z1 minus Z2. This wouldn't be log, this must be imaginary. Imaginary part of Z1 by Z2 is what we need to find. Must be imaginary part, it's a typo. This really means Z1 must be like this, Z2 must be like this. Mod Z1 is mod Z2 plus mod Z1 minus Z2. That means P, Q and O must be collinear points. This is what it means, right? And therefore, very clearly, amount by which you must rotate the denominator vector. So argument of Z1 by Z2. The amount by which you must rotate the denominator vector Z2 so that it coincides with the numerator vector Z1 is 0, or it could be pi depending on the relative orientation. So in any case, if it is 0, this means it must be purely real. Z1 by Z2 must be real, and if it is real, its imaginary part must be 0. Right? Why
can't we take a log?
No, you can, but you will get nothing out of it because you don't have any more information on this. Log Z1 by Z2 you want to take. Okay, I mean, unnecessarily if you want to take, I have no issues. But take Z1 is R1 e power I theta, Z2 is R2 e power I theta. Take the log of this here. What's my problem? Which would be log R1 by R2, which would be log mod Z1 by Z2. If you enjoy this, then this is all that we can say about this. Right? Are you okay with this? You want to take the sine of this also? Cosine? Mod of Z1 by Z2 is 1, and it's given. Argument of Z1, Z2 is 0. We need to draw some conclusions from this. This means mod Z1 is mod Z2. That's for sure. Say each is R. This means argument Z1 plus argument Z2 is 0. So argument Z1 is minus argument Z2. That means if argument Z1 is theta, then argument Z2 would be minus theta. And they have the same modulus R. That means in the Argand plane, if this is Z1, with this being theta, this being R, then Z2 would be, argument would be minus theta. Such would be Z2. They are conjugates of each other. Yes or no? Mirror images of each other about the x-axis. And now just check with options, whatever is required. Z1 of course is not Z2. Right? So option A is rubbish. Option 2, right?